says, given the following table, how can you tell it represents an absolute value function? Write the equation and graph the function. So this is one that is hard to spot immediately, but once you kind of see patterns, it gets a little bit easier to see. So when I just start looking at this table, if I didn't know it's an absolute value function, before I start graphing things, I kind of just look at my ordered pairs for a second, see if I can find a pattern. So I've got -3, 0, 0, -2, 3, -4, 6, -2, and 9, 0. What I notice is that my y values are repeating themselves, and they're kind of evenly spaced out. So I have a hunch right away that this is going to be my vertex. I'm actually going to start with that ordered pair first. So 3, -4, be right there. Now I'm going to work my way outwards. 0, -2, and 6, -2 are going to look like that. Now, if I have just these three ordered pairs, you could convince me that this is a quadratic equation, right? But when I go further still, I get -3, 0, and 9, 0. There's not a quadratic equation there. This is looking like it's going to be a nice absolute value function. Now, it could be something more crazy, because we only have 5 ordered pairs. It could be something ridiculous, but this makes sense as an absolute value function. So now, I have to write my equation. Well, since I've found my vertex already, I know I'm going to have y equals something times x minus my h value is 3 plus k. Well, since k is -4, instead of writing plus -4, I write -4. I need to fill in this little space right here. Well, I count out my slope. Up 2, right 3, 2/3. That's my answer. I double check my parabola, or not my parabola, excuse me. My absolute value function is opening upwards, so my a value has to be positive. If it had been opening downwards, I would need this to be a -2/3, but since it opens up, it's a +2/3. Hope that helps. Have a great day, everybody.